Students, in this video today we'll be learning how to solve linear systems by using the linear combination method. Okay, linear combination method. Now, remember, we have already learned two methods for solving linear systems. Remember, we learned the graphing method from lesson 7.1, and we learned the substitution method from lesson 7.2. Okay, so theoretically, as long as you've done your work and learned your math, when this video is finished today, you should know three different ways to solve linear systems. Okay, here's your heading for today. Please copy this down. Solving linear systems by using, by using the linear combination method, lesson 7.3, and be sure to include today's date. Alright, copy this down, please. Solving linear systems by using the linear combination method, lesson 7.3, and be sure to include today's date. Now, I am not going to give you steps for this method. Sometimes steps are necessary. Steps are really not necessary for this method. Instead, I'm going to give you an example to start off with, and in that example it kind of explains what we're going to do, what our goal is, and then we'll springboard from there into more difficult problems. Alright, so that's our goal for today. Here we go. Please copy this first problem in your notes. Please copy this first problem in your notes. Alright, now remember, anytime during the video if I go too fast, just pause the video and get caught up. Okay, let's solve this system. Now, you could solve it on your own if you wanted to graph each linear equation and see where they intersect. Or you could use the substitution method, and all of those methods are fine methods, but we're going to use the linear combination method. Would you please do something that's interesting? I would like you to add these two equations together. Can you do that, please? Let's add them together. What's 2x plus 4x? 6x. What's positive 3y plus negative 3y? Well, you could put 0y, but really we just say this. They just cancel out. Okay? Bring down your equal sign. What's 16 plus 8? 24. Okay? Everybody okay with that? I'm not asking you to understand why we did that. I'm not asking you to explain it. I'm just simply saying everyone should have the ability to add two equations together. That's pretty simple, right? So when we add these two equations together, we get out another equation. Do we not? Sure we do. Now, I would like you to stop and write down a sentence in your notes, okay? I'm going to type that sentence for you, okay? Copy this sentence in your notes, please. Okay, there's the sentence. It should have popped up on your screen. Please copy this down. It's very, very important, okay? In a linear system, please copy this in your notes. This is very, very important. I know it's a little long, but please copy this down. In a linear system, when you add two equations together, you get out an equation that you can use to solve the system. In a linear system, when you add two equations together like we did up here, you get out an equation like we did right here. Look at this. That you can use to solve the system. So when we added these two equations together right here, we get out this equation. We can use this to solve the system. So this is so easy. 6x equals 24, right? Divide both sides by 6. And what's x equal? X equals 4. So the only thing left to do now is to simply solve for y, and I'm finished, right? Isn't that true? So you say, Mr. Earhart, which equation do I use? Do I use the top equation? Or do I use the bottom equation? Guess what? It doesn't matter, and I'll show you. X equals 4. So where x is, I'm going to substitute 4. Okay? 4 times 4 is 16. Bring your 16 over and make it a negative 16. 3y equals 0, so y equals what? 0. Now let's do it over here. You get the exact same thing. equals 0. Divide both sides by negative 3. Y equals 0. So we're finished. 4, comma, 0. Your x and your y. There's your answer. Okay, now let's go back and think about this for a second. So what I just taught you was this. You're allowed to add two equations together, okay? And when I did that, my y's canceled out. Does everybody see that okay? Everybody see that? So, let's think about this for a second. Please copy this next problem down in your notes. Please copy this next problem in your notes. Sometimes when you add the two equations together, what if nothing cancels out? Then we have a problem, don't we? In fact, don't copy this next problem down, but in this problem here, we're going to do this one next after we solve this problem here. But in this problem here, if we add the two equations together, nothing cancels out. So we're going to talk about those in just a second, okay? But anyways, copy this problem down like I just said to do. Let's go ahead and add these two equations together, okay? And let's see what happens. Negative x, positive x, they cancel. Negative 3, that's negative what? 6y. Negative 6, positive 12, that's positive 6. And look at that, I have a nice, easy equation with just a y. There's no x, I have just a y. Divide both sides by a negative 6. These cancel, and y equals a negative 1 because a positive divided by a negative is a negative, and 6 divided by 6 is 1. Now, y equals negative 1. I have to take one of these equations and use them to solve for x. Well, I just showed you in the last problem, it doesn't matter which one you use. So, let's use this bottom one because I've got space right here to show my work. So, x, negative 3, here's y. Y equals negative 1. A negative 3 times a negative 1 is a positive 3. Bring the 3 over and make it a negative 3. And x equals what? 9. So there's my answer. 9, comma, negative 1. Alright? Now let's not, as the saying goes, lose sight of the trees for the forest, okay? Don't forget that what you basically just did is you found where these two lines intersect. Now I know, guys, you also found the solution to the linear system, and that's fine, that's good. So this is the solution to the linear system, I got that. But it's also the place if you were to graph these two lines. If you were to graph this linear equation and this linear equation, they would intersect right there. 9, negative 1. Please don't forget that, okay? So what we're doing in linear combination is we're adding two equations together and getting out a third equation that helps us solve the linear system. Does that make sense? But the last two problems have been pretty, I guess I'd call them just perfectly handpicked for this type of stuff, like in the first problem we did. When you added these two equations together, these canceled out. In the last problem we just did, when you added these two together, your x's canceled out. So it really doesn't matter if we cancel out the x's or the y's. But now we have a problem. What if we have a situation like this where nothing cancels out? If I added these two equations together, I would get 5x. That's a negative 4 and a negative 1, so negative 5y equals 10. Look at that. That does not help a bit. Not at all. So here's what I have to do. I have to multiply this equation by something that will help my x's cancel or my y's cancel. So here's what I'm thinking. I have a 4 right here, correct? A negative 4. Wouldn't it be great if I had a positive 4 right here? It really would be, wouldn't it? So, here's what I'm thinking. Right now I've got a negative 1 right here. Now if I multiply this bottom equation by 4, and by the way, yes, you're allowed to do that. If I multiply the bottom equation by 4, that'll give me right there. 4 times negative 1 is negative 4. And a negative 4 is not going to cancel. However, if I multiply the bottom equation by a negative 4, that'll give me a positive 4 there. Do you guys see that? So there's really no steps I can give you. You have to look at the equation and say to yourself, do I want to cancel out my x's or do I want to cancel out my y's? I always go with the one that is easier to do. For example, see this 3 to 2. You could multiply the top equation by a negative 2. And you could multiply the bottom equation by a positive 3. You could do that. And that would give you a negative 6 here and a positive 6 here. And that would work. But that's a lot more work. For me, it's easier to eliminate my y's in this problem. So I'm going to multiply my bottom equation by a negative 4. Let's see what happens, okay? My top equation stays the same. My bottom equation, negative 4 times 2, that's negative 8. Negative 4 times negative 1, that's positive 4. Negative 4 times 3, negative 12. Look at that, students. I am now ready to add these two equations together, and look what happens. Positive 3, negative 8, that's negative 5x. Look at your y's, negative 4, positive 4. They cancel out. That's good. That's what I wanted to happen. 7 minus 12, negative 5. Now divide both sides by a negative 5. And x equals positive 1. Now, please listen to me carefully. Where are you going to substitute this 1 in for x? You have 4 equations. 1, 2, 3, 4. Well, guess what? You can use any of those 4 equations you want to use. It doesn't matter. Any of them. Now for me, I'm going to use this equation because I have space right here to show my work, okay? So forget the 4. I'm going to use this equation right here, okay? So 2x minus y, so 2x, x equals 1, minus y or negative y equals 3. 2 times 1 is 2, negative y equals 3. Bring your 2 over and make it a negative 2. Bring down your negative y equals 1. So if negative y equals 1, then y equals negative 1. Just change both of your signs. So there's your 2 values. So your answer is 1 comma negative 1. There it is. Pretty simple, guys. It's not that hard, okay? Okay, let's continue on. Okay, now students, you can work ahead or you can watch me. It's up to you, okay? On this problem here, obviously if I add these two together, nothing's going to cancel. Okay? Nothing's going to cancel if I add these two equations together. So I've got to I have to make my x's or my y's cancel. Now in the last problem, to me it was pretty obvious the y's were easier because I had a 1 right here. Okay? That's my opinion. Here, I mean, they're both going to take a little work, okay? But one thing I do notice is this. Here's an idea to think about. Notice both of your y's are positive. Do you see that? And you're never going to cancel anything. Never. Unless one sign is what? Positive, and the other sign is what? Negative. So you can cancel your y's, but you're going to have to multiply by a negative number somewhere. I'm going to cancel my x's. And you know why I'm going to choose my x's? Because one number is already what? Positive, and one number is already what? Negative. So that's just what I'm going to do, okay? Okay, I've got a 3 and a 4. So I could very easily make both of these numbers become a 12, right? I could multiply the top equation by what? 4. That would give me a 12 right here. And multiply the bottom equation by what? 3. That would give me a negative 12 right there. So let's do that and see what happens, okay? 4 times 3x, 12x. 4 times 5y, 20y. 4 times 6, 24. Now take your 3 and multiply it through. 3 times negative 4, negative 12. 3 times 2, positive 6. 3 times 5, 15. Don't forget to multiply your number all the way through times all of the numbers, okay? Now I'm ready to add my two equations together. X's cancel. 20 plus 6, 26. 24 plus 15, 32. divide both sides by 26. These cancel. Y equals now 13 goes into both of these numbers, so we can reduce this. 13 goes into 39 three times. 13 goes into 26 two times. So look at that. We did it. We found y. Y equals 3 over 2, or you could say 1.5, or you could say 1.5. Okay? So that's what y equals. Now, we have to go back and put this in for y. We can do that here, or here, or here, or here. I'm going to use this equation because I have space down below to show my work. So negative 4x, positive 2. Here's my y. For y, I'm going to substitute 3 halves. Equals 5. Now, think this through, guys. 2 over 1 times 3 over 2. Your 2's would cancel, leaving you with 3 over 1, or just 3. There we go. Now bring your 3 over and make it a negative 3. And we're left with negative 4x equals 2. Alright. Divide both sides by negative 4. Negative 4's cancel, and x equals, now watch your signs. You have a positive over a negative. That makes the whole fraction negative, and 2 over 4 is 1 half. So your answer is negative 1 half, comma, 3 halves. And there is your answer, just like that. Okay, students, I hope this is making sense. Last problem. Okay, here we go. Now, in this problem here, I want you to pay close attention. To me, it's kind of common sense, but for some students, it's not. As you look at these two equations, notice they're in a different order. This top equation has its x term, then its y term, then its equal sign, then its constant term, like all the other problems I've had. But this equation has a y term, then an equal sign. It's all messed up. Okay, now look. You have to make sure the two equations, are you listening to me? You have to, you must, or you will miss the problem. You have to make sure both equations are in the same what? Order. Do you understand? You have to do that or you're going to miss the problem. So you have two choices. You can take this top equation here. I would not take any notes right now. I would just sit down and I would just sit and watch. You can take this top equation and change it. Bring your 3x over and make it a negative 3x. And you're left with 2y equals 8 negative 3x. Okay? Now that's fine. Look what you have. You have your y's, then your equal sign, then your constant term, then your x term. I have no problem with that, okay? That is totally fine to do. Or you can take the bottom equation and change it so it matches this one. So bring your 5x over and make it a positive 5x. So you're left with 5x positive 2y equals 12. I hope none of you tried to add these two together and get 7xy or something like that. Remember, you can only add or subtract like terms. Okay? They have to be like terms, and x and y are not like terms, so you cannot add them. So I took this equation, I rearranged it to this, and now look, they match. X's, then y's, then equal signs, then constant terms. So do you get what I'm saying, guys? You have to make sure your two equations are in the same order. Now, obviously I've done that. I'm going to leave mine like this. So I took this equation here, and I changed it to this, so I'm going to get rid of this, okay? It's gone. There. Now, let's go ahead and solve this system. Hey, look at this, guys. My y's are almost ready to cancel. Almost. I have a positive 2 and a positive 2. If I could make one of those two negatives, that would be okay. So I can multiply the bottom equation by a negative 1. That would give me a negative 2 right there. Or I can multiply the top equation by a negative 1. It doesn't matter, okay? Alright, here we go. Negative times a positive is a negative 5x. Negative times a 2y is a negative 2y. Negative times a positive is a negative 12. Bring over your bottom equation, and we are just about finished. Alright, here we go. My y's cancel. Negative 5, positive 3, that's negative 2. Negative 12, positive 8, that's negative 4. Divide both sides by a negative 2. Your negative 2's cancel. Do not forget that a negative divided by a negative is a positive, and 4 divided by 2 is 2. Now pick up this 2 and substitute in for x either here or here or here or here. I'm going to use this equation here. So 3x, x is 2, positive 2y equals 8. 3 times 2 is 6. 6 plus 2y equals 8. Bring your 6 over and make it a negative 6. 2y equals 2. Divide both sides by 2 and y equals 1. So your answer is 2, comma 1. Alright? And that's it, guys. Okay? The linear combination method is a great method to use on some systems, and sometimes substitution is better, okay? Sometimes graphing is better. But that is how you solve systems, by using linear combination. If you have any questions, don't hesitate to call or email.